So what happens when you have a group of university students, engineering students, who are part of a project that is built specifically for a competition on endurance? And it's like no other vehicle we featured. It's a solar-powered electric car. Kate Arsenault. So what is Kate's job with the Dal Solar Car Project?
Yeah, I am the fundraising and electrical lead of the solar car team.
Electrical lead, that sounds
It sounds
exhilarating.
easier than it is.
Sounds electrical. And you get to drive this.
I do get to drive it.
What made you want to be a part of the team? How did that happen?
Actually, it was through August. Me and her were on a different society together, and she introduced me to the team, and I've always been very interested in renewable energy and clean technology, and it just was a perfect fit for what I want to do after I graduate, so here I am.
So August, how did you get involved with the solar car plan?
I first discovered this team right out of my first year. I had just switched into environmental engineering from chemical.
Wait a minute, so you're not an electrical engineer?
Not an electrical engineer, not a mechanical engineer.
And you're involved in one of the engineering department's major goals, projects, and plans?
Very involved, yes.
Why? Well, how did you get here from there?
I always wanted to join a design team. I came across that they needed a social media manager on Instagram. That was already in my wheelhouse as something to do, so I joined when there was about 5 of us on the team, and it's been 2 years, yeah.
What is it that you want them to know about it, this whole project?
I am so proud to be a part of the solar car team. We're one of the most diverse teams, and I think we're one of the closest teams on campus. Being a part of this team has helped me not drop out of engineering multiple times. I can say that with my chest. But I am really intrigued with renewable energy. I feel like in Canada, we'd be a little hard pressed to have actual solar cars out on the road, but it would be really cool to be a part of those first stepping stones for actual solar cars on the road.
So Noah, how long have you been involved with the solar car project here at Dalhousie?
I've been on the team since January 2022. Mm-hmm. So the team was founded in 2021, so I've been here pretty much since the beginning.
And where did this chassis come from? Where did this originate?
So the car itself, the chassis and the top shell, which you can see here, was purchased from another team. It was one of their old cars. And then, so that got us started. That got us the mechanical portion of the car, or the majority of it. Mm-hmm. And from there, we built the battery pack. We did all of the electrical. We got the car working again. And then this year, we also built the canopy. But other than the chassis, we've done pretty much everything to make this a working vehicle again.
So when you got it, it was an open-air roadster, kind of?
Yes. Well, actually, last year we did race it without the canopy on it.
Right. And what is the purpose of that? Is that aerodynamics? Is it to protect the driver, the operator?
Mostly aerodynamics, because these cars are all about efficiency. They don't have a lot of power, and we have to use that power for a long time. But it also does offer some protection for the driver.
You have your T-shirt on from the track, the facility. Who sets this up? What is the association? How is...
So the event is American Solar Challenge, which is, that's the name of the organizer, but the race itself, there's 2 races. So there's FSGP, which is Formula Sun Grand Prix. That's what we race. That's a track style event. And right now is ASC, which is American Solar Challenge. So for the teams that are doing that, that's I think it's a 1,500 or 2,000 mile cross country race in the US.
That is a pretty ambitious undertaking. How did that feel, seeing the field of entrants and knowing that some of them didn't even make it to the track that day?
It felt honestly very proud. I felt very proud of our team. We're probably one of the smallest teams, newest teams to go out to race and to finish second in all of our scrutineering and to get out on the track and race all 3 days. Like, we did that.
The bar was high.
Yeah, and a lot of teams that had more funding, have been going for 20 plus years, weren't able to do that. So I think that really shows how much effort this team puts into this car.
We planned immediately. Joelle's first.
The plan for the rest of the day is to do as many laps until we get stuck and need to get physically towed in. That's what we did yesterday, and that's the plan now.
What is going through your mind as you are taking the car around, knowing that you're trying to do an endurance run? Mm-hmm. You're trying to go as far as you can, not necessarily as quickly, but if you're not moving quickly, you're not getting any mileage in. So what do you, is it a strategy as a team?
Yeah, exactly. So we are always in constant communication with like the pit crew. I'm also always looking at the dash and looking what the voltage and the amperage that I'm drawing while I'm driving the car. We tried to keep it around 8 amps or so that we were drawing. For some of the hills we had to go up to like 30 amps, but 8 amps is probably about 25 miles per hour average, and that's what we were able to keep to kind of make the car go as long as possible without completely draining the battery really fast.
Do you have any control over that? Clearly, if it's a difference in elevation, that's physics. That's not you.
Exactly. So it's really just about how, if you're like fully pushing down on the throttle or if you're kind of being easy with the throttle, is how much amperage you're drawing. But again, for those big hills, you need to push a little bit further down on the throttle to be able to get up, and that's where it's drawing like the 30 amps. But everything else is just about when you're going down, coasting completely, or just like using the throttle a little bit.
Yesterday it was 6 laps. I don't think our last lap counted, and that we charged from about 8 in the morning to 12 noon. It was really cloudy, and we did 6 laps, and we got to get towed in. That was Kate driving yesterday, right, Kate?
How do you stop it?
It has disc brakes on each wheel.
Okay, so not just pulling the power off, you're also able to stop.
It does have regen braking, but for full stops, it has disc brakes, one per hour.
And it is generating electricity. What are we talking about? What is the voltage? What is it when this is at peak performance? What is it putting up for voltage?
So the car always runs off a battery pack, and then while it's running, the solar cells are able to charge the battery pack. So when the car is fully charged, it's at roughly 120, 125 volts. And the solar array is capable of producing anywhere from, I think it will charge anywhere from 80 to about 150 in that range. And then it has power trackers, which make that to a more stable voltage for the battery to see.
What does it sound like?
Like being in the car?
Yeah.
Oh my God, it's loud. It's so loud.
How is that possible? It's electric.
I know. It's just like the bumpiness of like the everything kind of being not so structurally together, if that makes sense.
Yep.
But yeah, it's just rattly is all it is, but the motor isn't super loud or anything.
And not a lot of insulation like a modern car would have.
Yeah,
so
exactly.
how hot is it in the...
When you're just sitting in the car, it gets so hot. But when you're actually driving, there's a lot of airflow. Like nothing's airtight, and we also have that forced air vent up there, so it's not so hot while you're driving. But when you're sitting in the hot heat in Kentucky, it is quite warm.
This is our mascot.
When you come to a project and you go, all right, we have the people in place, we have a goal in mind, what's our budget? Tell me a little bit about what it's like to manage a project like this and to be involved with the people who are pretty much trying to get everything done as least expensive as possible.
Absolutely. We just came back from race last week, and I've been talking to teams about what they thought their car was worth. And the lowest I heard was well over 2 times what I think at least our car is worth.
Okay.
So I feel like for our team, budget is the thing that's holding us back.
But in some ways, I guess you could say it's giving you another reason to accelerate other areas where it might not just be about money. It might be about, I don't know, technique or new technology, maybe?
Absolutely. We've been recently looking into encapsulating our own solar cells as a way to slash costs by a lot. These ones right here were encapsulated by a former team, and they, at race last week, taught us how to do it as well. So I think a lot of the team member, that's going to be a big project, learning how to attach them, solder them together, and attach them to build our own array. I feel like that'd be really cool to build it from the ground up.
I have enough to make a solar panel. You can see over here with this one.
Do you now put race car driver or solar car driver on your resume?
Yeah, I'm
on
gonna,
your CV?
professional race car
Nice.
driver, I think.
Nice.
Yeah.
Looks like a lot of fun.
Yeah.
It looks like it's a bit of a challenge to get inside of this car.
Yes.
It is?
I need a stool.
Okay. I was wondering how that happens because it doesn't seem like it's, I mean, I'm not being disrespectful here, but it doesn't look like it would take somebody standing on it.
Oh yeah, no, we
Without
have some
damaging it.
mechanical supports underneath
Okay.
it, but yeah, I do need a stool to get in.
Well, I can't wait to see what this is like in motion. I know I saw some video, but that's not quite the same as seeing it in real life.
Absolutely.
We have bare spots here. What's going on? Why are there spots that don't have solar panels? You would think they should be all over the car.
When this car was originally built, the regulations for the race stated that it could have 6 square meters of solar cells. Now that's been changed to 4.
So that's a scale that keeps moving down, I assume, as technology gets better?
It probably won't go less than 4, but
Okay.
it's just the rules changed, so that way nobody keeps building the same cars. They try to change out every few years to keep it interesting. And because this chassis already existed, we just took 2 square meters of cells off of it.
These cars vary widely as to the way teams approach how they want them to look, and I assume it all has to do with function.
Yes.
Okay, so what does that mean?
So most cars are designed to be as aerodynamically efficient as possible. Ours is not very aerodynamic right now, but that's going to change. So a lot of the cars you would have seen are super skinny, just so there's less just air friction. But in the future, we definitely want to make ours smaller, skinnier, and definitely more aerodynamic.
Right, and I assume that it was thought, okay, the more surface area, the more sun, that will create the electricity through the photovoltaic cells, and then it's going to make it go further, not necessarily faster.
Yes, this one right here was originally built using a 6-meter array. Then about 2 years ago, I believe, FSGP went down to a 4-meter array. So that's why we're missing a few patches. We took off the most inefficient cells, and we have just 4 meters of cells that are working the best. So in the future, it'll probably just be, I think we'll stick with the 4-meter one, but we could go back to 6 meters if we wanted to.
So when you were doing laps and you're watching how much power you have, how much power or electricity is being generated from these solar cells, and it stops.
Yeah.
What was that like for you?
On the first day, it was cloudy, so I knew that we weren't going to be able to sit there for a second and get any generation from the sun. So I kind of had to give up on the first day. But on the last day, it was sunny, and I was going up a hill, and the voltage dropped below 80, and that's when the car will shut off because it's like a safety thing for the battery.
Right.
So it cuts the car off, and I start rolling backwards, and I'm like, oh no. So I put on the emergency brake, I shut off the car, and I radioed everyone that I'm like stuck. And then they're like, okay, we'll come get you. And I'm yelling, no, I'm gonna restart this car, give me a second. So I restart the car, I turn on the power trackers, which let the solar array charge like into the battery. And then I'm like, okay, I'm just gonna wait here for a second. I can see that the battery is charging right now. And so I turn it back on and I slowly go back up the hill and finish the lap. So the last day was good because of the sun, but first day we did have to get towed back.
What song were you singing as you were doing laps?
I'm pretty sure I was singing Walking on Sunshine.
How fitting is that?
I know, it was just popping into my head.
No, that's a very fitting tune.
Yeah.
Very fitting tune.
Very true.
Let it go.
Amazing. We made about 6 laps. I think we averaged about 9 or 10 minutes each lap, which is what we want to preserve energy. So I think it was pretty good.
And the idea of this team is to build something that is as green or as efficient as possible. How does that compare with other teams who are going for, say, speed or distance, or maybe do you have to choose one or the other? Is there, an inverse proportion there?
It's all about efficiency. This car is capable of going 60 to 70 kilometers an hour, but usually we run it closer to 30 or 40 because for our event, we have to run this car 8 hours a day for 3 days. So it sees a total of 24 hours of track time, and that's on one charge of the battery.
And a typical lap, it's quite a long facility.
This year the track was fairly long. It was 3.5 miles or 3.15 miles, so that works out to about 5 kilometers per lap.
And it has elevation grade, so there are times where you're going uphill?
Yeah, so the track we raced at last year was fairly flat. It was pretty easy to keep up a decent speed. But this year there was one dip in the track that was approximately 40 feet deep, and then there was a steep hill climbing out of it. So that used a lot of power.
It sounds like you're having fun.
Oh yeah, it's amazing. And I feel like this is the first time, I actually get to driving it at the races, the first time that I realized that we made a solar car, because when you're driving, you can see when you're charging and when you're discharging. And there would be times where I had my foot on the throttle, but I would still be charging. I would be net positive into the battery. And I'm like, oh my God, we actually made a solar car. It's from the sun is why it's charging right now. So yeah, it really clicked for me. I knew we had a solar car, but yeah.
It's in that moment, it's real.
Exactly.
and you see all the other teams, and the other team members are saying it's a very supportive environment,
Yeah, very much.
unlike some sports where it's highly competitive.
Yeah, no, everyone is like sharing knowledge and sharing learnings there. Everyone wants you to succeed because if no one else is racing, then you don't have anyone to race against. Yeah.
What do you think they learned from you?
I hope they learned, like, we talked to a lot of teams about like mechanical stuff and our roll cage, which is something new that we designed this year. We did take a couple teams through our electrical system and our battery pack as well, because our battery pack is very well designed. I must say we did a great job on our battery pack. So we did explain a couple teams like how our battery pack worked and what we used. So I hope they took a little bit of learnings from that.
Hi, Kate.
Hi, Sheldon. Nice e-bike. That's a big difference than your diesel guzzling car.
Well, you know what? What really matters is this experimental technology. So what's your charge at right now?
Right now, we're at about 50%, which is 113 volts.
I think that'll give us enough power to run a bus. So
I think it will.
I think we should take it for a run, see how it works.
Absolutely. Sounds good.
Okie dokie.
All right.
How did it feel competing with teams that had much deeper pockets, much better financing in general?
Yeah.
How did that feel?
I mean, we knew that going into it that there would be teams who have a lot more funding than we did. So we weren't expecting, I don't think, to like succeed greatly in the actual race portion of it. We were really proud to be able to come second in the scrutineering inspection portion. We had that nailed down. But yeah, I think we just went in knowing that even though we don't have the most efficient, most expensive things, we still did this and we still made it work, and we were still so proud of ourselves.
You're right. It looks like it's hard to see out of that thing.
It is indeed hard to see, a little bit, but that's okay.
All right. So you already, is that as fast as it goes? I'm not judging. What's it actually rolling on? What's that?
It's rolling on Michelin scooter tires. So they're a 14-inch tire for motorcycles or scooters, and the rims have been custom machined.
Okay. And what is the drivetrain? What is making this thing move?
So this car is powered by a single in-hub brushless DC motor, and it powers one of the rear tires.
Okay.
And that's the entire drivetrain.
And so one is powered, the other is just rotating freely?
So one wheel is powered, all the other wheels are free to rotate.
Everything is off the shelf for the most part? Or is it off the shelf and then
The materials
tweaked
are off the shelf,
Okay.
but almost everything is custom on this.
for the application itself?
Even the cells. The cells themselves are off the shelf, but they've been encapsulated by the team that originally built this car.
So what does that mean, encapsulated?
So the cells themselves are soldered together, and then they have a layer of light-absorbent film on the top, and on the back side there's 2 layers of fiberglass, and it's all bonded together with epoxy.
Yeah, you can just keep driving.
I saw you and the team spritzing water on the cells. What's the purpose of that?
It helps to cool down the cells, makes them a little more efficient. Now, we can't do that continuously, but whenever we stop the car, we come into pit to change drivers, we're allowed to spray it with water for a few
Okay.
minutes just to help cool them down.
They have rules about that?
Yep. So the rule is that we can't have more than 5 gallons of water at a time.
At one application or,
Yeah.
okay.
And it has to be a hand sprayer, it can't be powered or electronic.
Okay. So you did how many laps? How much time were you in that car?
Probably maybe like 4 hours total.
Wow.
Yeah.
So is this about as fast as you were driving on the track or faster?
No, I was driving about 25 miles per hour. I'm going about 5 miles per hour.
Oh, okay.
Just to keep up with you.
What? Yeah, okay, fine. You want to keep up with me? Keep up with me. Ah, wait, I got more gears. Oh, no. Oh, darn. That thing works pretty good. That is pretty cool. I'm squeaking here. All right, I guess we'll do another turn. You talked about the scrutineering. That's another layer or level of what happens. What does happen? How is that carried out?
For the first 3 days of the race, we'll say, they come and they inspect pretty much every portion of your car. They inspect mechanical, electrical, your array, your battery, a whole bunch of different things. Every time you go out on the track, they check to make sure that your your lights and horn work. So yeah, there's a whole bunch of inspection criteria that you have to meet to even be able to get onto the track.
Right.
Yeah.
And it is kind of surprising to me that they want you to have signal lights or indicators, brake lights that work.
Yeah.
I suspect it's all about safety.
Exactly. It's not the same like 360 view that you would have in a regular car where you're able to shoulder check because there's a roll cage in front of you, you have a helmet that's restricting your view. So you have your backup camera, and then every time that you pass a car on the track you have to use your horn as well, and then you use the indicator lights and everything. But yeah, it's all about safety and making sure that everyone is competing safely.
Sheldon, did you want to hear the horn?
I think that's a great idea.
Absolutely.
Oh boy, sounds like the harbor in this fog cloud. That is very loud. Very cool.
Yeah, very Maritime inspired.
What is it about this project that intrigues you? I won't say excite you because you don't look like you're very excitable.
It's just about, the main thing would be finding ways to progress technology, make things greener. So it's not something you would typically see a solar-powered vehicle, so it's an interesting project to work on.
Yeah. What do you think the future is for these?
It's hard to say. Like, they're still at a point where they're not viable as everyday vehicles, but they are, every year they progress a little further.
So with the technology, clearly electric cars is a proven technology. You can go and buy one today.
Yeah.
Hydrogen is in its infancy.
Yep.
What about the future of solar? Is it even feasible?
You know what? My personal belief, I think that if we just threw solar cells on top of electric vehicles already, you could get that much more mileage out of them. Like, it would just be something additional. It's like the same thing as regen braking. You'd have another thing that's charging your battery so you could go that much further. Now, being able to run just off of solar car may not be super feasible until we get really efficient solar cells, but to be able to just throw them on an electric car and put it right into the battery pack, I feel like it should be done.
A lot of the cars are very Jetson fashion-esque.
Yeah.
Especially like the Illinois, like the orange too. That gives me Jetsons.
What is the timeline? How long can you be involved as a student at Dalhousie, who I assume is looking towards a career someday outside of the university environment?
Well, the good thing about this design team, it's technically through Dalhousie Engineering, but you don't need to be an engineer to join the team. And we have had senior advisors, almost students that have graduated, alumni, or even just outside people that are interested in helping the team. So you don't have to be a Dalhousie student to be a part of the solar car team. Solar car love.
We did so good.
We did, and you were speeding. I was like, Kate is so happy in there.
You just spent 3 days in Kentucky?
Yeah.
And you just finished and you made the final lap?
Yeah.
You called someone?
I did. I called my mom.
And what did mom say?
Mom was so proud of me.
Oh.
Yeah, she was so happy for me, and she was just so proud of our team. And I hadn't seen her for like a week, so I was already missing my family. But yeah, I called my mom and told her all about it and how I coasted into the last lap across the finish line, and she was really proud. So yeah.
Oh, well, I could tell. that moved you then, and it moves you now.
Yeah.
Last time I died at 7% or something. I couldn't get it back up, but like the sun was just shining and I was going. Running on sunshine.
It takes a team.
It does. It's not just Noah, August, and I. It takes a whole lot of our team, and this is a couple of our other team members.
My name is Joelle Corpinaz, and I'm the mechanical support.
I'm Kieran Muller, and I'm operations support.
My name is Michelle Yee, and I'm the operations manager. My name is Alia Raza, and I'm electrical support.
I'm Owen Studdard, and I'm the battery lead.
I'm Grant McCormick. I'm the mechanical co-lead.